Welcome to the Explainer. Today, we're going to demystify one of machine learning's most powerful and, surprisingly human tools, the decision tree.
I mean, have you ever done this? Sat down and sketched out the pros and cons, the if this, then that? If you have, then you're already thinking like a decision tree. Seriously, that simple, logical process is exactly what we're going to get into.
So, at its very heart, a decision tree is what's called a supervised learning algorithm. But honestly, you can just think of it as a really smart flowchart. It's designed to ask a series of questions to lead you, step by step, to a single, clear answer.
And that's really their secret sauce, isn't it? They don't use some kind of alien logic. They follow a clear, step-by-step path that feels really familiar because it's pretty much how we think through problems ourselves.
Okay, let's make this totally concrete. Imagine you get a new job offer. How would a decision tree actually handle this? Well, it wouldn't just look at the whole thing at once. It would start breaking it down into a series of key questions.
So first, the tree asks about the money. Is the salary over $50,000? Let's say yes. Okay, great. Next question, is the commute short? Yes again. And what about perks, like a cab facility? With each yes, we're traveling down a specific branch, getting closer and closer to that final decision. A no at any one of these steps, that would send us down a totally different path, probably ending in decline offer. And that right there is the fundamental logic in action.
So we've got the basic idea down. Now let's learn the actual terms that data scientists and engineers use. Once you understand the anatomy of the tree, you can really see how it all works under the hood.
Okay, think back to our job offer example, that very first question, the one that kicks everything off, that's the root node. Then each question inside the tree, like is the salary over $50,000, that's an internal node. The yes and no answers, those are the branches that guide our path. And the final outcomes, accept or decline, those are the leaf nodes. That's where the journey ends, no more questions.
But this brings up a really critical question, right? Out of all the things it could ask, salary, commute, perks, company culture, how does the algorithm know which question to ask first? It's not random. It's actually a very, very clever and calculated choice.
See, the goal is to find the question that gives the most clarity right off the bat. A perfect split, the absolute ideal, would mean that after just one question, all the data in one branch leads to one outcome, and all the data in the other branch leads to the opposite. It's all about achieving maximum clarity as fast as possible. So how does a machine actually quantify what a good question is? Well, it uses some clever math, with metrics like information gain and the Gini index. Just think of it like this. Information gain rewards the questions that give you the biggest aha moment, the ones that clear up the most confusion all at once. The Gini index, on the other hand, is kind of like a neat freak. It looks for questions that create the most uniform groups, sorting everything into nice, clean piles.
That idea of information gain is built on a concept from physics called entropy, which is really just a fancy word for randomness or disorder. So imagine a data set where half the job offers were accepted and half were declined. It's super messy, right? That's high entropy. The goal of a good question is to reduce that entropy, to slash through the chaos and create groups that are much less random and much more certain. But, a tree can actually get too smart for its own good. What happens when it grows too big, too complex, and starts learning the data maybe a little too well? Well, this leads to a super common problem in machine learning called overfitting. An overfitted tree is kind of like a student who has just memorized the answers to a practice test, but doesn't actually understand the concepts. It gets a perfect score on the practice test, but then fails the real exam. It's memorized all the little quirks and random noise in the training data, which makes it less accurate for real-world predictions. So what's the solution? It's something called pruning. And yeah, it's exactly what it sounds like. Just like you'd trim a real tree to make it healthier and stronger, we strategically remove the branches that don't add real, genuine, predictive power. The whole point here is to make the model simpler, more generalized. By snipping off the branches that are just focused on noise, we create a tree that better captures the true patterns in the data. And here's the wild part. A smaller, pruned tree is often a more powerful and more accurate one. Less is more. Okay, so let's put this all together. Why should you care about decision trees? What is it about this simple flowchart-like model that makes it so foundational in the world of AI and machine learning? Well, it really all comes down to clarity. Unlike some of those black box AI models where you have no idea what's going on inside, you can actually look at a decision tree and understand exactly why it made the choice it did. This transparency is absolutely crucial in fields like medicine or finance. And because they're so flexible with data, they're used for everything, from predicting if a customer is going to leave a service to figuring out which of your emails are spam.
From predicting what you might buy next to helping diagnose medical conditions, the simple, elegant logic of the decision tree is a foundational block for building intelligent systems. It really makes you wonder, doesn't it? What's the next complex human decision that will teach a machine to map out?